Warm welcome to everybody in the Pinnacle Infotech Solution Series, Building the Future and Introduction to Infrastructure BIM, where me, Debasish, and Amitava will be talking about BIM infrastructure in BIM solutions. Before we start, a brief on the introduction to Pinnacle capabilities. Pinnacle Infotech offers building information modeling services to AEC firms globally. We provide design and consulting services, pre-construction services, constructability reviews and coordination, value engineering, logistics planning, construction management, facilities management, and digital twins. In the last 30 plus years, Pinnacle has implemented 15,000 plus projects across 43 countries for the global AEC industry. We have state-of-art campuses in Durgapur, Jaipur, Kolkata, and Madurai. We have delivery centers in US, UK, UAE, Singapore, Japan, which enables us to give the clients 24/7 services. With this brief introduction, let us go deep dive into the topic of the day.
Okay. Thank you, sir. Thank you for the introduction. So myself, Amitava Chakraborty. I am taking care of the infrastructure BIM from Pinnacle. I am associated with Pinnacle last 12 years, and currently I am working on so many various type of infrastructure project in Pinnacle. So today, this is our scope of presentation, like challenge in infrastructure project, infrastructure BIM, different vertical, benefit using BIM, infrastructure project stages, and how BIM help during bid stage, construction stage, as well as the handovering stage. So this is our small presentation for today. So we will start with the challenge of infrastructure project.
Yeah, before Amitava deep dives into the challenges, I mean, we all agree that most of the infrastructure projects, we hear it is not defined properly and also goes through constant changes and reviews. We also see a lot of statistics worldwide on mega projects, significant cost overruns, and delays in commissioning. So now I request Amitava to talk about the challenges specifically in infrastructure projects.
Yes, sir. Thank you. So first of all, like a lack of clarity and consistency of objective and standard. So there are so many standard issues while we are working any infrastructure project. So this is the main difference with the other vertical. Like in infrastructure, in a single project, there are so many subcontractors, so many designer involved into a single project. Like if I consider a road project, road along with the underground utilities. So for road and underground utility, at least 8 to 10 different type of designer involved in a project. And mainly the objectives of the owner is to hire the world best designer for their project. So sometimes we get some designer from UK, from US, from India. So in different area, different type of designer working in a single project. And at current days, we are not all time going on site to check the site condition. We are getting some data. We are digitalize everything. We are getting the survey data and we are working from back office. So while designer working on any project, they have some separate mindset for their design. Every time also they don't understand or don't know what is the existing elements in their project site already exist or not. So there are some lack of clarity about the project area, project condition, and the potential issue, potential risks of this project. So everyone prepared their design based on their mindset. And while all the design drawing, all the design intent come up in the construction site, the construction team find out so many issues like a clashing, like some material issue, some unavailability of the material or this type of size or standard. So there are multiple type of issues they are facing. While we face so many issues, to overcome the issues, the cost and the time both will extend from the plan. So this is another issue for every infrastructure type of project. Then the lack of communication and collaboration between different stakeholders. Like as I mentioned, there are so many interface parties, so many designer and subcontractor associated with a single project. So they need some proper collaboration. They need some proper communication. So current days, like in Saudi Arabia, there are so many infrastructure projects currently going on. But the contractor, the designer, someone from Germany, someone from USA, someone from UK or any Asian country. So there are various type of time zone difference. So it's totally tough to communicate properly between all the designer, all the stakeholder at a time, only with their design drawings. And the complexity, complex regularity or environment and quality control. So if this type of issue continuously happen, there is so many issue we can face for quality. So if we implement the BIM, we can overcome those type of challenges. So after next couple of slides, we can elaborate entirely the BIM benefit, how BIM help to reduce this type of issue and overcome this type of challenges.
Yeah, thank you, Amitava. Before you deep dive into the verticals, let me have a brief on why infrastructure is so important and we should talk about using BIM to improve the efficiency. Uh, let's talk about Vision 2030 of Saudi Arabia, which is a $1 trillion pipeline of infrastructure projects. We are seeing that manifested through giga projects in NEOM, Amala, Red Sea Global. Similarly, in the rest of Middle East, some giga projects are coming up. In India, the National Infrastructure Pipeline, which is a 1.5 trillion USD infrastructure project, has been announced and is going on. We also have in US, we have the Build Back Better program. In Canada, also major infrastructure plan. In the APAC countries, the Build programs are gaining steam. And also in the European countries, huge infrastructure projects are starting. So if we have BIM in infrastructure to improve the efficiency of these projects, I mean, it is a great, to all stakeholders, it's a great benefit. Now, can you talk about the verticals, please? Yeah.
Yeah. So like infrastructure, we simply segregate the entire infrastructure vertical into 5 different parts. First is the road and highways. It's very known item like a road, any type of road and highway project. Then the bridge and tunnels. These tunnels also include the railway or the metro tunnels also. Then the airfield project. While I am saying about the airfield, this is the entire airport project. But we consider the terminal concourse, this type of part as a building part, and the airfield and airside and landside both under the infrastructure part. So airfield, another vertical for our infrastructure, then rail and transit, and finally the water and wastewater. While I am saying about water and wastewater, this is not only the drainage, not only the storm sewer or any type of water network only. This also include the water diversion structure and dam also. So this is our infrastructure vertical, which we are working right now. And the very next slide, I would like to explain about the benefit of using BIM. And before starting to elaborate all the point in detail, I would like to know some of your thought, what your understanding, what your feedback about the BIM benefit of infrastructure project.
Yes. I think what you explained, and that was a very important part that you talked about. So there are different stakeholders in an infrastructure project, starting from the government agencies, the developer, the EPC contractor, the designer, the PMC guy. So BIM undoubtedly, and you will be explaining in details, actually improves coordination between these various parties. And that is the core importance.
Yes.
The second complexity of infrastructure projects is that they're linear in nature. I mean, they usually traverse thousands of kilometers. So there also to visualize that in your drawing board and see how is it progressing, how is it has been conceptualized. I think BIM has the big role to play. And you were also now you will be talking about GIS, how it improves that. So I think these are the two core areas where BIM has a big role to play in infrastructure projects.
Yes, yes. Thank you, sir. Thank you for the brief. So I would like to start explanation about all the benefit. Like a first benefit, like accurate quantity takeoff. So the quantity takeoff means the BOQ, which the material takeoff or material quantity. For every project, we need some takeoff for the budget, for estimate, and also the material ordering. So very initial stage before bid, we need some of the bid quantity to understand the total project budget. And during the project, we need to take off the quantity based on the pouring sequence, based on the construction sequence to order the material. And finally, to clear the invoice of all the contractor, we also need the proper quantity. So this is very important part of quantity takeoff. Now, in the traditional method, it need to be done by using the only the 2D drawing or some Excel file. There may be some potential issue, potential risks to take the actual quantity, because sometimes the uh, network, some pipe network, some manhole, some road, some bridge layout maybe changes. So there are some certain change like a few millimeter or few centimeter. So this type of change we need to redo in our traditional process. But in case of using BIM, where we already prepared the parametric 3D model, we can easily update our model based on the design changes. We can easily segregate the model based on the construction sequence, and from that particular model we can get the accurate quantity for each and every stage during design, during construction, and during the handover also. The second is the design review and validation. So sometimes it's also required to review the design like a water flow. Based on the design requirement, the water flow is proper or not. Suppose we are just preparing some ponds, something like a pond design, some retention or detention basin design. So based on the data, we just calculate, we prepare the design, we prepare the model, and then if we using the BIM, some BIM tool, some BIM software, we have some option where we can easily check whether our design is okay or not. So we can easily validate our design. We can review our design. We prepare the model. Suppose some underground utility. There are 7 or 8 total number of network we work. So we just receive all the design document for separate subcontractor or designer, prepare the model, and run the clash test, and we can easily understand whether everything are clash free or not. If there is any potential issue, we can do the coordination meeting with the particular designer. They can update their design, and before construction we can get the totally clash free coordinated model. Based on that, we just prepare the drawing, and that drawing directly used to our construction site for construction. So there is no design issue during the construction. Then the constructability analysis also. Sometimes our model, our design is class free, but this is not a constructible. Suppose if I give you some example, if suppose two different network, one electrical network, one water network, both are run parallelly, and between both the networks there is only 10 millimeter of gap. So this is not a classes, but this also not the constructible. So we can review this type of constructability, whether this is constructible or not. And based on that, we discuss with the designer, and designer update their design based on the requirement. Then the value engineering. For each and every type of BIM project, we normally do the value engineering. After completing the entire design, we just try to find out whether there is any way which minimize the material cost, which minimize the installation cost or maintenance cost, but the functionality has been same. So we try to find out this type of cost reduction, And if possible, we can do the value engineering for each and every project also. Then the progress tracking, we generally prepare the 4D simulation. While we prepare the 4D simulation, this is a very initial stage. We prepare the 4D simulation based on the baseline schedule. And while the project start construction on site, we are getting some data from the construction team regularly. And based on that, we are updating our 4D model. So at a point, anytime based on the requirement, we just mapping between the baseline 4D and current 4D, and we can easily understand what need to do and what exactly has been done. So we can track the progress and we can track what our plan and what is the actual. Then the fewer rework, which I mentioned in the design review and validation stage, if we find out all the potential classes, all the issue during the design review, so the rework also less, then the less error also. If all the potential risks, potential issue, we can find out in our virtual construction during BIM modeling, the error also less. Increased collaboration. One important thing, like several type of subcontractors, several type of designer working on a particular project from different region, from Europe, from US, from India, from Asia. There are multiple type of time zone. So due to time zone difference, it's critical to do regular coordination meeting or regular communication. So if we use the BIM, current days for BIM, we normally use the BIM 360 or ACC as a cloud server. So if our everything in cloud server, this is no matter which time zone any contractor or any designer are working, they are getting the entire model, the live model from the cloud, and just coordinating with their model, with their design. And we can also do the coordination meeting based on the classes, based on the report. So the collaboration also increase. Support operation and maintenance. So after completing any project, there are so many maintenance also required. After a couple of years, there are some maintenance required. Suppose one airport project, we build an airport, and there are so many light fixture. Now, every light fixture has some of their life cycle. So after the longevity, after the time, proper time frame, we need to replace that particular light fixture. So how we can understand when we need to replace any light fixture? If I need to replace any fixture, to whom I can order, from where I can get this type of fixture. So this every type of information we accommodate into our model, that is called the asset information modeling, AIM. So after completing the construction, once we prepare the as-built model, we also include each and every information, not only the area, not only the level. Along with that, we also incorporate the supplier, the vendor, the URL of the vendor, everything we accommodate into our model element. So that anytime for maintenance, for operation, anyone can check that, okay, this is the longevity, this is the life cycle of this particular item. After this time period, we need to replace this, and we can get this from this vendor or this contractor. So all the information into a single model which is in cloud, and the particular authority, the concerned person, have some access to review the model every time. This is also the asset management. So this type of information we just feed it with all the elements, and this during the asset management, this is also beneficial. And the logistic planning validation. So this is also a good part. This is not logistic planning. This is not for only the infrastructure project. This logistics planning validation we can use for each and every type of project. Sir, you remember we work on the Lusail Stadium, the big stadium where the FIFA World Cup.
Yes, yes, yes.
So in Lusail Stadium also, the logistic, there is a logistic plan. There are so many tower cranes. So if all the tower cranes start working in a same time, there may some potential issue of clashing between all the tower cranes. So what we did for this project, we just use our 4D analysis part. We just model all the tower crane for the logistic planning validation, and we review which time we need to increase the height of which crane, so that there are around 8 tower cranes simultaneously used, but we just maintain their height. Someone around 50 meter, the same time the beside tower crane is only 30 meter. So we avoid the potential clashes. So this type of logistic planning validation we can do for each type of project. So these are the main benefit of using BIM for infrastructure projects.
Thank you. So nicely explained.
So now this is the infrastructure project stage, bid to handover. For every type of project, while project start, we start with the bid stage and finally the handovering stage. So while elaborating these stages, I would like to explain the two different type of project. One is design, bid, build, and another is design and build project. So there are two different type of project mainly in infrastructure. So what we are seeing, the mainly the project, the major project is the design and build project. This is the more challenging project, and the BIM mainly beneficial for those type of project where the design continuously going on, along with that the construction also going on. So there is no the IFC drawing before start the construction. There is only the design drawing. So just after bid, the general contractor get all the final design drawing, or you can say the preliminary design drawing, and their in-house team start reviewing the design. Their in-house team try to uh, some value engineering, accommodate some value engineering to reduce some cost, reduce some maintenance cost or installation cost, and continuously they are changing their design. Along with that, there every type of project there are some separate standard. So they also try to maintain their standard properly. So this is the main challenge. The design continuously changes. Along with that, their construction also going on. So that time BIM is mainly helpful for this type of project, because if my model already prepared in a by using any BIM tools like a Revit or Civil 3D, any type of this type of software, or currently we also started using the different type of Bentley software like Open Bridge, Open Rail, Open Road. So we already have some parametric model. Now, based on the requirement, if your design will change, we just update our model based on the changes, and each and every data which require for the construction, like the 2D drawing, 4D simulation for progress tracking, quantity takeoff for material order. So every this type of data we can get automatically from our updated model. So BIM also very beneficial for design build and design bid build any type of project. So to elaborate this thing, I would like to elaborate how BIM help in bid. So if anyone just bidding for any project, sometimes some of the general contractor or some owner want to use the BIM during their construction stage for to get the maximum BIM benefit. But what we are saying that you can use the BIM not only the construction stage, you can start using BIM from bid stage as well. Why you use this slide? There are only 5 points I mentioned. These 5 points are exact benefit, which benefit you can get during the bid. First is extract the quantity from BIM model for bid. So during bid, you need some budget. You need to extract the quantity, and based on that, you prepare your budget and you submit your bid. So you can extract the quantity from BIM model in a proper way and error free quantity takeoff. So if you prepare your model, you easily extract the quantity from your model. Initial class coordination to understand the complexity of the project. So sometime while some general contractor just bidding some project, they just consider, okay, there are 5 or 7 type of utility pipe, or this is my project, and based on that, I will get the preliminary design drawing, and from preliminary design drawing, I just prepare the construction model and construction drawing, and finally complete my construction. Apart from that, sometimes some project there are some issues, some complexity based on the design. If we do some initial class coordinate before bid, sometime based on our experience, we also found in a project that I just mentioned you, in a airport project, very big airport project, we worked during the bid stage. And in very initial stage, we received around 12 or 13 number of design model. And we did the class test, and we found there are around 1,70,000 classes between 12 model. So if these type of classes, and this is my design build project, after we win this project, my design team need to update all the design to prepare the class fee model. To remove the 1,70,000 classes, we need some additional effort. So this type of understanding we can get during the bid if we do the initial class coordination. Then the 4D sequencing and animation video for presentation. We can easily prepare the 4D sequence based on the planning for to the approval authority. In front of approval authority, we can showcase that this is the 4D sequence. If we start work like January 2024, we can complete in after 2 years, and this is my progress, month-wise progress. Along with that, we can prepare some good animation video for presentation purpose. 5D model using baseline construction schedule. We can also prepare some 5D model which elaborate the cash flow of the project, the required cash flow of the project. And along with that, we can also study the alternative design. Sometimes for suppose some steel structure, there are some certain design, and the contractor, the bidder, just thinking to change the design. So easily prepare some alternative design into their BIM model, and not prepare some drawing or something to showcase in front of the approval authority. Just showcase their alternative design by using the BIM model. So this type of benefit we can get from bid. Then quickly go through the construction with BIM model. So this is the first point, like a 3D modeling for visualization. So whenever we prepare the 3D model, it will better for the visualization. Then the coordination between other trade model. In BIM benefit part, we already discussed several times that this is the main benefit. We can coordinate with other trade, other vendor, and if there is any classes, we can resolve before construction. Then the constructability review and analysis. This like whether the design item constructible or not, we can review this type of constructability. Then the value engineering, quantity extraction for material supply. So we can do the exact quantity extraction for material supply. So there are sometimes some storage issue on site. So for that, it's better to order the material based on the construction schedule. So based on construction schedule, we just segregate our model, and from the 3D model, from the BIM model, we easily extract the material quantity, and we can order our material based on that quantity. Then construction drawing from class fee model to work on site by the construction team. We generate the construction drawings from our class fee model, and 4D for progress tracking. So in initial stage, we prepare just initial 4D based on the baseline construction schedule. During construction, we start receiving some construction data directly from our on-site team or construction team. So we prepare a different model for construction, and we mapping both baseline and construction model, and we can prepare some data which showcase what actually need to do, means what is the plan and what actually have been done. So plan versus actual data we can easily understand from 4D. Then finally, the handovering stage, project handovering stage, as we discussed during the BIM benefit, there are some maintenance work required, some operation work, and the asset management. So to support this type of job, what we have done, we prepared the as-built model. So as-built modeling means the construction model which we prepare. There are sometimes there are very minor difference between construction model and as-built model. Just as an example, suppose in a manhole, I just plan to build a manhole for a particular area, but during construction, sometime for some manual error or sometime for some specific reason, I need to move the manhole 20 millimeter. So this information not in my construction model or construction drawing. To store this type of information, we prepared the as-built model. After construction, we receive the entire construction data from the construction team and we prepared the as-built model, and also the same information reflect into the as-built drawing, which in future which beneficial for any type of operation and maintenance. And the asset information for facility management, and sometimes we need some cost mapping, bid versus construction. Sometimes the owner need some data, some detail, because as in initial stage which we discussed, in infrastructure project, sometimes there are some over budget, over cost also required. So why we need to pay some extra? Sometimes owner need to understand about this in detail. So if we use the BIM, I have a design model, I have a final as-built model. So I can easily just link both the model and I just extract some data, what is in my bid model and what is my final as-built model. From that, we can easily understand which area we spend some extra amount, extra effort, and this type of mapping sometimes required during the handovering stage also. So this is the entire benefit of BIM for bid to handovering stage.
Thank you. You have beautifully covered all the areas in infrastructure where BIM can play a role. Thank you.
Yeah, thank you, sir. Okay, so that's all from my end for today. Sir, if you want to add anything.
Yes, and we look forward to hearing our valued customer talking about this same thing.
Okay, thank you all. Bye.